at the onset of Indo-German Research Day 2024 being organized by DVR, New Delhi. We, the Council of Scientific and Industrial Research, India, would present our sessions to you for inviting participation. In this session, previously we have presented the research ecosystem of CSIR, where a general overview and opportunities for participation with CSIR and building India-German S&T collaboration, and the research and development portfolio of CSIR, wherein the missions and the ongoing missions and projects were showcased, along with some success stories. Now, we will be presenting to you the technology portfolio and contract research capabilities of CSIR, who are your partners in research, development, and translation. I am very happy to introduce Dr. Vibha Malhotra Sani, who is an outstanding scientist and the head of Technology Management Directorate and head of Innovation Protection Unit at CSIR headquarters, New Delhi. She would be presenting this session, and we look forward to your queries, your questions, and interactions to take forward Indo-German S&T collaborations. With this very brief, I request Dr. Vibha ma'am to please take the floor. Ma'am, please.
Thanks, Mohit, and a very good afternoon to all of you in this particular workshop who are participating here, both from India and, of course, Germany and different parts of Europe. Warm welcome once again. Delhi is warm, but an extra warmth we are showering on you from Delhi. So very briefly, I'll just try to recap what I'm sure Rama did give in the introductory slide. So I'll just share my slides right now. Okay, so I'm sure this has already been, the next slide. The organizational structure has already been shared with you, and also the total, a very brief about CSIR, our vision and our mission, and also the present manpower strength in CSIR. We are spread across the length and breadth of the country, 37 labs, 39 outreach or extension centers across the country. And again, very briefly, what exactly CSIR has been doing over the decades. The indelible ink, in fact, all of us have just voted in Delhi, and this mark of democracy, as we call it, is the invention from CSIR. So in the 50s, we started with that. And going further down the decades, wherever the country required, some scientific interventions, CSIR has been playing a very major role through the decades. A very brief profile of our decade-wise contributions. The IP portfolio of CSIR, in fact, we started building it up way back in 1996 itself. We were the first ones in India to come up with our IP policy much before the country laid down the IP policy. And we've not looked back. We are very comfortably positioned, whether you see it within the country or globally also. Of course, we compare ourselves with organizations like CNRS, Max Planck, and Fraunhofer and all. We are, I will not say that we are anywhere close to them, but yes, there is probably just some comparison. We're not faring any less than them. And this calls for a closer collaboration, which our international division is very well doing. In fact, the very basis of this workshop emanates from that only. This is our present IP portfolio. In fact, although over the years we've been granted, thousands of We filed and we got grant of about 8 to 10,000 IPs across the decades since CSIR's inception. But as of now, as of let's say 31st March 2024, we have a lean but a strong patent portfolio. And I'm very happy to say that we don't, keep a bulky patent portfolio for the simple reason because we want something which is commercializable, an IP that's commercializable, that is of strategic interest to CSIR and also to the country. That is what we maintain. And even in the EP, our EP patent portfolio is about 383 patents. And of course, amongst them, the unique ones are 133. I mean, 383 is, of course, this 133 is spread across different European countries. Rama did talk about the thematic focus of CSIR. And as was told to you in our earlier session, we are spread across 8 themes. And this very briefly gives the close interaction of different labs and the interconnects of different of our 37 labs across the 8 themes. And very briefly, I'll just take you through the focused areas of each theme. So the first one, the aerospace, electronics, instrumentation, and the strategic sector, that is the AISS theme. We are focused on the civil and military aviation, as well as aerospace, advanced materials and the fuels, the mechanical systems that go into it, electronics and embedded systems, medical instrumentations, as well as smart agriculture. So this again is not only focused on aerospace, largely focused on that, but across different themes. We have the electronics and embedded systems and medical instrumentation. So this is how the interaction amongst the themes also happens. When we talk of agriculture, nutrition, and biotechnology theme, the focused areas are, of course, agrotechnologies. And CSIR is focused a lot on medicinal and aromatic plants. We also focus on biostimulants, biofertilizers, and crop improvements through breedings and transgenics, the nutritional security, enzymes, including industrial enzymes, farm mechanization, value addition, precision farming, all that comes under our focus of agriculture, nutrition, and biotechnology. Under the civil infrastructure and engineering theme, we focus on not only the buildings, the building materials and the building physics, but also structural health monitoring, life extension, disaster mitigation, automation, robotics. Again, waste to wealth plays a very major role in this particular theme, but also across different themes because we are working towards building a circular economy within the country. Rural infrastructure is also another focus here, and mobility, infrastructure, and planning, again, is focused here. In the chemical sector, our chemical theme includes leather as well as petrochemicals. We focus on C1 chemistry, biomass to chemicals and leather, the agrochemicals, marine chemicals, including potash, fertilizers, salt, and magnesia, active pharma ingredients and key starting material, sustainable chemistries, AI ML framework for accelerated design, as well as performance and fluorochemicals. Ecology, environment, earth, ocean, science, and water is a very vast theme of ours, and it covers not only the solid earth, but also ecology and environment around us, the oceans, water, as well as wastewater. Energy, both conventional as well as non-conventional, and also the energy device. This theme focuses on coal energy, We are focusing here on clean coal technologies as well as gas and gas hydrates, the petroleum, bioenergy, including bio-waste to energy, energy conversion and related devices, hydrogen energy, including hydrogen economy, energy materials and energy storage devices, as well as energy management. Healthcare, our focus is on precision health and cohort building. And of course, in that, we focus on wellness and disease biology, the diagnosis, surveillance, technology, drug development, therapeutics, all that comes in our healthcare theme. In the 4M, that's mining, minerals, metals, as well as materials theme, we have the focus on advanced materials and processes, including the 2D materials, lean and low-grade resource processing, strategic material, strategic metals from both primary and secondary resources, as well as engineering critical assessment. I'll just walk you through a few of our technologies. This is not the complete technology portfolio of CSIR, but just a glimpse of the technologies portfolio that we have built up, and also where we are open to collaboration. Lithium ion battery technology as well as pilot plant. My colleague Vandana would have, of course, touched upon the mission mode projects that we have in this particular domain. So this is one pilot plant that we have set up in PPP mode. And another, again, in the energy sector, we have developed the technology for drop-in liquid sustainable aviation and automotive fuels. This is also, in fact, comparable to the international standards. The ASTMD standard is mentioned here. Another process is catalytic dehydration of methanol to dimethyl ether. Then in the fuel sector, again, fuel cell sector, we have the low temperature polyelectrolyte membrane fuel cell technology for automotive application. I'm sure in the hydrogen to technology domain, Vandana would have focused on this particular thing, but this is an entire technology portfolio that we have been able to build up. We've shown through the fuel cell, the running of fuel cell bus on green hydrogen, as well as recently, along with industry, a vessel, in fact, a ship, a ferry did sail through on hydrogen fuel. We also have electrolyzers technologies, be it the PEM electrolyzer, polymer electrolyte membrane, or the solid oxide electrolyzer cell technology. These are both technologies which are at higher TRL level, and now we are working on the MRL level, and also to take it up towards commercial development. Another thing in fuel cell is the testing station, that the test station to test the PMFC stacks. This has also been set up. In the chemical sector, we have, in fact, we collaborated with industry, and our hydrazine hydrate commercial plant has come up in Gujarat. And in fact, the first consignment was flagged off in June last year. This is another important milestone where Indian footwear is concerned because of, I mean, we are a kind of a boiling pot of humanity here. All kinds of diverse ethnographies are found in this particular South Asian region. And what was sort of, in fact, small ailments, these could be cured through proper footwear sizes and wearing proper footwear. So this is where the need for an Indian footwear size was firmed up. And we've now come up with, of course, our Central Leather Research Institute had worked on this. And we have a new standard, that is the IS 1638 standard that has been developed for footwear sizing of the Indian population. As I said, we've been working a lot on waste valorization across all our themes. This is one example from our civil infrastructure engineering theme, where the slag road technology has been demonstrated. Slag, as you know, the steel slag is a waste from the steel industry. And we've demonstrated this. And in fact, across a couple of national highways, in a few stretches of road, this technology is being used. Another technology that has been used in construction of roads is waste plastic. And again, our Central Road Research Institute has not only demonstrated this, but also this has been taken up in developing the roadways across the national, of some of the sectors of the national highways. Under the waste to wealth itself, we have potash fertilizer from the distillery spent wash. In fact, India is an importer of potash, and this is one such technology that has been developed. And it is not known whether there is any global commercial product of this kind which is available. But this particular product is free of, it's potassium-free vinasse, and it's a FCO grade product. And again, a zero waste process has been developed. In the battery sector, this is another such thing, a pilot scale facility. I'm sure Vandana did talk about the mission on battery recycling. That is one such thing we are working on for the mapping and tapping of minerals. And this one pilot scale facility at the National Metallurgical Laboratory, Jamshedpur, has been set up. This is an important technological development which our Trivandrum lab has done, the National Institute of Integrated Science and Technology. They have transformed the pathogenic biomedical waste to value-added soil additives. It's somewhat like manure only, and in fact, this has been tested as well. And right now, it is being evaluated by the Pollution Control Board to make sure that there is no spread of pathogenic waste due to this. But just to get that certification. However, this has been demonstrated, and a couple of places this also has been set up. And we have not found any spread of pathogenic waste in those areas. In the healthcare sector, we have taken up this important aspect of developing a breast cancer genome atlas from the tissue samples, in fact, the DNA of the tissue samples from patients. And this again is a requirement to develop the gene signatures of patients of Indian origin, in fact, of this ethnicity. And other areas that we are working on in the healthcare, of course, is cancer, to making cancer care more affordable, be it developing different technologies in the diagnostics as well as the therapeutics area. And also for the translational neuroscience to understand the key biological pathways which are involved in neurodegenerative diseases. In the agri-nutri biotic sector, we are working on seaweed cultivation across the Indian coast. In fact, we are in the process of identifying, and we have identified about 249 sites across the coastal region of India where commercial cultivation of seaweeds, different seaweeds could be taken up. This is one part of it. And in fact, as a societal role, we have involved, in fact, and we have placed this as an additional source of income to the fisher women across the coastal areas. The cultivation technologies have been given to the self-help groups amongst the fisher women, and they have taken this up, commercial cultivation of seaweed across the coast. Apart from that, for the industry, we are also working on zero waste discharge process for alginate production, as well as for molecular biology grade agros. And these processes have been developed, and we'd be happy to collaborate and discuss these things further. CSIR Aroma mission, in fact, this was taken up, as I said, that in the CSIR, we focus a lot on cultivation of medicinal and aromatic plants. So this is one such mission that was taken up across the CSIR labs, not only as an endeavor to provide some additional source of income to the farmers, promoting cultivation in areas where normal food crops cultivation was found to be challenging, be it in the rain-fed areas or also the other flood-prone areas and other challenging areas where irrigation was a problem. So this did provide a lot of, to a lot of clusters, in fact, across the clusters that we have formed within the country of different aromatic plants. So these clusters, there has been an additional income given to the farmers. In fact, farmers have gained additional income here. But also on the other hand, we've been able to help the aroma industry in the country to get quality essential oil. And from there, not only the quality essential oil, but also very high value chemicals, aroma chemicals, which is used by the flavor and fragrance industry. So I'll just take you through those also. This is another mission, the floriculture mission, similar lines of aroma mission. We launched this. And this again has provided additional source of income to the farmers. Apart from this, what we are already also doing in the country is doing the fragrance mapping across some of the regions of the country, where we could get certain, flowers cultivation, commercial cultivation of the flowers could be done of similar fragrances. So that fragrance map is also being developed. And of course, we have developed some products for the MSMEs also. So these are some of the aroma molecules which are available for collaboration, for licensing, and further development also with industries abroad in the European region. This will be, in fact, this is at different scales that is available, and we are open to collaboration in this field. In fact, all those from 17 to 24, 25, these are the molecules which are the reference molecules and reference standards. These can be used by the industry, and these are also available at lab scale. We are open to collaborations, and these are some of the areas where we do seek collaboration. Of course, it's a commercialization of the natural aroma molecule technologies, and also development of value-added products from them, and including the spent biomass, exploring global market of natural essential oils, and exploring opportunities again with flavors and fragrance segments, and also What we are doing under our aroma and mostly, in fact, the floriculture mission is also developing region-specific honey. And we are also developing NMR signatures for these honeys. So any collaboration, anybody interested, you're most welcome. We do welcome collaboration in this sector. Another important mission that we've taken up is under the cotton mission. This is for developing defense in plants against some of the common insect pests like pink bollworm, the fall armyworm, as well as leaf armyworm is one such thing, and also white fly. So we have both the chimeric Bt toxin as well as non-Bt insecticidal proteins. These non-Bt insecticidal proteins have been in fact extracted and purified from different ferns which are available in the repository of our National Botanical Research Institute. Sorry. So this pink bollworm technology is indicated here. How we have worked this out, and some of the results are shown in this particular slide. And as I understand, pink bollworm is a major problem in Europe as well. And the lab does invite collaboration in this particular field. This, of course, the GM technology, as I said, the non-insecticidal Bt toxins that have been developed and introgressed into the cotton plants. The results are here of different proteins. And again, collaboration is most welcome for whitefly insect pest technology as well. Another mission mode project that we have taken up is developing smart agro-technologies for precision farming and crop management. And this we've taken in different regions in the country to get the predictive analytical tools for early detection of crop stresses, which are driven by microclimate observations. And since this is a very, a sector where CSIR has just entered, we are open to collaboration in this particular field as well. Aircraft development under our AEISS theme is another particular technology domain that we are working on. We are working on regional transport aircraft, the design and the development. And in fact, our laboratory, National Aerospace Laboratories, has had discussions with a number of aircraft OEMs, both within the country as well as the international OEMs, including some of the European ones like Airbus. And we do look forward to participation from partners in Germany, especially for to be partners and to participate in our special purpose entity that we are developing for this, and also to act as our partners and suppliers and designer as well as developers in different the full scale engineering, including series production phase. So I again request all those who are interested, please do join us in this, and especially if Airbus could come in. In fact, there has been a lot of discussion with Airbus by NAL, and we do welcome the discussions, furthering those discussions. NAL has also developed the trainer aircraft. It's a lightweight trainer aircraft, the Hansa NG, and this has been certified by DCGA. The type certification has been received, and although we've received orders for aircrafts from different flying clubs across the country. We are looking for production partners here. And this is one technology which is available even for those who'd like to license it for other global sectors. Drishti transmemometer is another development. This helps in acts as another vision to the pilots, especially in low vision areas when the vision is air vision is low. That is the time Drishti transmemometer is very useful, and this is there in a number of civilian airports in the country as well as in our defense airfields. And any party that's interested, they can discuss with NAL on this. So coming to what kind of collaborations we do have. Of course, we have all kinds of contract R&D, be it sponsored, collaborative, cooperative, grant and aid. Our labs also do consultancy work as well as technical services. And where licensing is concerned, all kinds of licensing is what we are open to. And also, we are open to assignment or sale of IPs as well as co-development with partners. A very brief snapshot of our association with industries, both globally. Over the past, I think 5 years or so, we've signed 113 NDAs and agreements and projects, as well as security sensitivity clearances, collaborations with industries outside the country, global industries. And we have, in fact, this, as you can see, is across not only Europe, but also US, USSR, Australia, and also some of the Asian countries. These are the broad areas where we have collaborated. So very briefly, in fact, I doubt if there's any sector where we have not collaborated with industry. Within the CSIR, we do promote entrepreneurship, and in fact, even with the industry within the country, the past 5 years, we have 531 technology transfers we've had so far. And we have 12 incubation facilities spread across some of our labs. And if you see the total number of incubatees that have benefited from these incubation facilities, it's more than 1,000. And in the past 5 years, over 600 plus entrepreneurs also have been developed. In fact, they are the ones who took our technologies and developed it further. So this is some of the incubation facilities in CSIR. These have been developed and these have been set up with the help of different organizations in the country, be it the Government of India Department of Biotechnology or the DSIR National Research and Development Cooperation, and also other such endeavors, the Department of Science and Technology. So this is all in project mode, which have been set up. And so thank you. I hope I have not exceeded my time, but we are open to any discussions.
Thank you, ma'am. In case if there are any questions on this platform, we'll be happy to take them. You can drop in the chat box or raise your hand. Or in case if our colleagues joining us from our YouTube and Facebook channels, if you have any questions, you can also drop in the chat box over there, and we'll be happy to take them as well over right now or maybe later. So
So in case, Vibha, you have any video to take us through on some of our technology developments.
Yeah, so could you play that video, Rama? There is
Yes.
a very brief video on the CSIR technologies, which we developed for the Technology Day. I think we could play that. That'll just give you a glimpse of the technologies and the facilities. Facilities, of course, they have been displayed. So the technologies of CSIR, we can just play that.
Ma'am, should we play or
Yeah, please. Yeah, please.
Yeah.
Thank you.
Thank you, ma'am. So in case if there are any questions, we'll be happy to answer them. I'm just checking in if we have any questions on our Facebook and YouTube channel, ma'am. Please give me a minute. So, ma'am, we don't have any questions, but many people are viewing our session. So, thank you for one wonderful talk and enlightening us with the technology portfolio of CSIR. I will just conclude by sharing a few slides and inviting participation. Give me a moment. So as Vibha ma'am has already indicated, there are various modes through which you can collaborate with CSIR, and CSIR India is a global technology partner, either through joint research, you can subcontract your projects to CSIR institutes, We have excellent facilities and infrastructure and trained manpower to do those projects. We welcome joint R&D projects, and we can develop joint R&D program with you for exchange of research scholars or any otherwise as well. We can organize staff exchange and training programs, networking, workshops, conferences, meetings for capacity building, joint contracts with industry. You can partner with us, and together we can work towards development for our industries together, and as also identifying relevant industries in areas of mutual interest. You can visit the link. These slides would be shared maybe by the VR, and they are also available on our website, and you can scan the QR code in case if you're viewing it right away, and you can be directed to how to collaborate page of CSIR. Once again, thanking you off, and we look forward to building upon our S&T collaborations with our German counterparts and inviting you to participate and work in CSIR through various programs that have been discussed and told. Namaskar, Jai Hind. Thank you, ma'am.
Thank you.
With this, we come to an end of this session. Thank you, everyone, for joining. Thank you, Vibha, ma'am. Thank you.
Thank you.
Thank you.